detail in section 3.4. So by the time we're finished with 3.4, you'll look at this and say, oh, I know how to do this. But still, this would help us in 3.4. What did 43 say?
2 times x cubed minus 2 times x squared minus 11.
Wait a minute, 2 times x cubed. Wait a minute, so I don't need parentheses.
No.
Just kidding. Okay, 2 times x cubed.
Minus 2x squared.
Minus 2x squared.
Minus 11x.
Minus 11x.
Plus 6.
Plus 6.
2 was a 0.
So 2 or x plus 2? 2 is a 0. What does that mean? It's a solution. What does that mean? It's an x-intercept. What does that mean? It's a root, right? All that means the same thing. That means x equals 2. So what they wanted you to do is they wanted you to solve this. They want you to find all the solutions. So you're going to go to synthetic division with your 2, because they told you that is a 0. So now you're going to do 2, negative 2, negative 11, and 6. So, and the reason why the remainder theorem doesn't help here is because it doesn't give you the polynomial. Bring down the 2. 2 times 2 is 4. Add. 2 times 2 is 4. Add. You're going to get negative 7. Wait a minute. This gives me 14. Something's not right. Something is not right. All right, so we're going to look at section 3.3. And 43 was 2. That's minus 5x squared plus x. Wow. Okay. So let's try this again. We've got 2x cubed minus 5x squared plus x plus 2 equals 0. And they're saying 2 is still our 0. All right? So we'll start over. We'll put the 2 in that position. So we have 2, negative 5. How did I know it didn't work? There was a remainder. If it works, what should it be?
No remainder.
No remainder. It should be 0. So we're going to bring down the 2. We get 4. Negative 1 gives me negative 2. Negative 1 gives me negative 2. Now that worked.
No remainder.
Okay. So the remainder theorem would still have given us 0, correct? What it doesn't give us is it doesn't give us this polynomial. Remember, this is the remainder. This is the term with no x. This is the term with x to the first. This is the term with x to the second. Do you remember that? So now that we've got this polynomial, what are you supposed to do? Set it equal to 0 and do what? You got two options. You can factor, or you could use the quadratic formula. All right, which do you prefer? I am so glad to hear that, because I think it's so much easier to do. All right, so how does this factor? 2x plus 1 times x minus 1 equals 0. So this gives me negative 2, positive 1, which gives me negative 1. So x equals negative 1/2, x equals 1. You did a U-try on this Friday. And what's wrong with my answer?
There's supposed to be 3.
There should be 3. Where's the third one?
X equals 2.
X equal 2, the one they gave us initially. Do you remember that? For some people, I had to say, remember, you got to do the original one. That's what you're supposed to do on 43, 44, 45, 46. So what they're telling you one of the zeros. Where we'll end up is we'll end up where they don't tell you the 0 and you have to find them by scratch. So that's our ultimate goal. And when we get there, then we'll be ready for a test. Any other questions on the homework? Okay. So do you agree that this could have been x minus 2 times 2x plus 1 times x minus 1 to give me these three numbers? So what we're doing today is we're starting here and we're going back up. What do you think? Easy? In other words, you start here, then you have to go to this step, then you're going to have to go to this step, and then you'll have to find an A. So let's see what we've got. And hopefully I have. It doesn't look like it. There. Finding zeros of a polynomial, no, it's not that either. Okay, it's right. Oh, I didn't spell that right, did I? Write a polynomial equation for a given set of real and/or complex roots. All right, that's our objective. The fundamental theorem of algebra says if f of x is a polynomial of degree n, where n is 1 or bigger, then the equation of f of x equals 0 must have at least one complex root. What does complex mean? It could be x equals 3. It could be x equals 3i. Isn't 3 the same thing as 3 plus 0i? So you see, this is complex as well as this. All right. Linear factorization theorem says that an nth degree polynomial can be expressed as a product of a non-zero constant. That would be a, and n, because it's nth degree, n linear factors, where each linear factor has a leading coefficient of 1. So they're saying that this is a 1, and this is a 1, and this is a 1, and this is a 1. So that really doesn't help us yet either. But that a is important, okay? So let's solve by factoring, and then we'll undo this. We'll say 0 equals x squared minus 8x minus 20. How do you factor? Well, the factors of 20 that subtract to give you 8. 10 and 2. So what does this mean? This means x minus 10 equals 0 and x plus 2 equals 0. That means x equals, and x equals negative 2. So we're going to undo the process. What does that mean? That means we start here. We start with x equals 10 and x equals negative 2. So what do we do? How do we go from this step up to this one? Subtract 10. And what do we do here? Add 2. Okay, so now we're at this level. Now what do we do? So now we're going to say 0 equals x minus 10 times x plus 2. Now what do? FOIL. 0 equals x squared plus 2x minus 10x minus 20, right? Or x squared minus 8x minus 20. Is that my function? Now, notice the coefficient of x squared was what? 1, right? Okay, so we didn't play with that a, did we? But we will be playing with that a. Okay, talk to me about what we just did in green. Does it make sense? Do you see how we're undoing the process? For me to just give you notes about this is what you do, follow my rules, is stupid. When you can see exactly how they took what we did and took it back to the beginning. All right. So they're going to say, first of all, whenever there's a complex root that has I in it or a square root in it, there must be the conjugate of that root. Do you remember what is that called? Quadratic formula? Opposite of b plus or minus what? Square root of b squared minus 4ac all over 2a. All right. So if your root did not simplify, all right, you would have negative b plus that root. Agreed? And then you'd have negative b minus that root. You see they come in pairs. So if you have x plus 4i, they will only give you this. What else do you have? What's the conjugate? X minus 4i. That is another root. If you have x minus square root of 5, you also have x plus square root of 5. If you have x minus I, you also have x plus I. If you have x plus square root of 2, you also have, if you have 3i, you also have negative 3i. Think of this as 0 minus, correct? All right. Got that? Okay. So now, a function has zeros 3, 5, and I. But what are all the roots? 3, 5, I, and what? Negative I. A function has the zeros negative 3, 6, negative square root of 2, but what are all the roots? Negative 3, 6, negative 2 square root of 2, and what? 2 square root of 2. A function has the zeros negative 4i and square root of 6, but what are all the roots? Negative 4i, 4i, square root of 6, negative square root of 6. Will you get this right if you don't pick up all the roots? And your polynomial is going to look funny because it'll have i's in it. All right, with that, okay, I think we can move on. So now, finding the polynomial, we're undoing this. If you want step-by-step directions, here they are. You write all of the roots first. Then you're going to set each root equal to x, and then move everything to one side, leaving 0 on the other. These are the factors of the polynomial. Now, you'll write these factors as a product with a, let me get a pen, with a constant factor of little a set equal to f of x. So it's going to look like f of x equals a times, and you got this string of factors. Then you'll multiply all those factors to get the polynomial, and they're going to give you an ordered pair. So you'll substitute for x, you'll substitute for y, and you'll be able to find a. So that's all you're doing today is this process. So these are online in PDF form, and of course if you want to watch the video. So 4th degree polynomial means when you're finished you have the x to the 4th. With real coefficients has, that's, do you see that? Do you see that? What is that? Negative 1 and negative 1. You know what I could have done? Let me rewrite this. Pretend, let's pretend. Let's pretend that this was not there. Okay? Let's pretend that they said negative 1 multiplicity of 2. How's that? 2i as its zeros, and there's your ordered pair. So, what are all the roots? What are they? Negative 1. And why did you write that twice? Multiplicity of 2. And negative 2i and 2i. All right, so those are your roots. Those were your answers. In other words, it was x equal negative 1, x equal negative 1, x equal negative 2i, x equal 2i. Now what do? What's your next step? You have to add the 1, so you have got 0. There's one of the factors. Okay, what do we do here? Add 1. There's a second factor. What do we do here? Add 2i. And that's a third factor. And now we're going to subtract 2i. And that's your fourth factor. So from here, we're going to say f of x is equal to some unknown constant a times x plus 1 times x plus 1 times x plus 2i times x minus 2i.
Where's the two negative ones?
Multiplicity of 2.
Oh.
Yeah. So you've got an option. Do you want to find A now, or do you want to find A later?
Let's get it over with.
I'm thinking it might be easier now because it's, well, the I's might make it hard. We'll do it later. Just kidding that I even asked you that. All right. So we have to start multiplying. Now, you are definitely going to want to multiply the I's by the I's first to get rid of the I's. Okay? I might as well go ahead and multiply those together. So how do I multiply the first group? X squared, what is this? 1x plus, which is 2x plus what? 1 times 1? All right. So now we're going to have x squared minus 2i plus 2i. Will that always happen? Minus 4i squared. Now look what a good review we're going to get of our complex numbers. This is a times x squared plus 2x plus 1. All right. So this is x squared. If this doesn't happen, you messed up. And that's going to be minus 4. What is I squared equal to? A negative 1. So you're going to have f of x is equal to a times x squared plus 2x plus 1 times x squared plus 4. All right. Now, what do we do? All right. So we're going to FOIL these. So we're going to say f of x is equal to a times, so we've got x squared times x squared, x to the 4th. We've got x squared times 4, which is what? 4x squared. We've got 2x times x squared, which is what? Okay, 2x cubed. We've got 2x times 4. Well, you know what? So now we got 2x times 4. What does that give me? 8x. I'm combining my like terms. What's 1 times x squared? X squared. Underneath the x squared, what's 1 times 4? So that kind of looks a bit nasty. It's better if the binomial were in front. So f of x is going to equal a times x to the 4th plus 2x cubed plus how many x squareds? 5x squareds plus 8x plus 4. What was our ordered pair? 312. How do we find our a? What do we do to find a? We put 12 in for y, and this is going to be a times 3 to the 4th plus 2 times 3 to the 3rd plus 5 times 3 squared. Yes, ma'am. In the very beginning, they told you f of 3 is equal to 12. See it? Okay. So you've got 12 equals a times, that's going to be 81. 27 times 2 is 54. 3 times 3 is 9 times 5 is 45. Wow. This is one ugly number. 12 is equal to a times, I have no clue. 81, 54, 45, 24, 4. 8 and 5 is 13, 17, 18, carry our 1. We've got 9 and 5 is 14, 18, 19, 20. How about 208? How do you solve for 8?
I was only 8 off.
What's A? What's A? 12 divided by 208. How does that reduce?
It reduces pretty good. What's this say that?
Well, I know that 4 goes into 12 how many times? 3. And how many times does it's going to go in there? 4 goes 52, yes. Okay, so what is our final answer? It's going to be f of x equals 3 over 52 times x to the 4th plus 2x cubed plus 5x squared plus 8x plus 4. Okay, so I think while you go, I'm going to go ahead and do one more example. So you can see another example online if you're interested. And this gap was left here because that was meant to be a square root of 2. So we have x is equal to square root of 2. We have x equals opposite of square root of 2, and we have x is equal to 5. So we're going to subtract the square root of 2. We're going to add the square root of 2. And then we're going to subtract 5. So from here, we're going to say f of x is equal to a times x minus the square root of 2 times x plus the square root of 2 times x minus 5. So I'm going to say a times, now I'm going to put my x minus square root of 5 in front, and now I'm going to do this multiplication. X squared plus x square root of 2 minus x square root of 2 minus square root of 4. So we've got 5, or f of x is equal to a times x minus 5 times x squared minus 2. So now we're going to go ahead and FOIL some more. We're going to have x to the third, and then we're going to have minus 2x minus 5x squared plus 10. The ordered pair they gave us is 1, 24. So I'm going to say 24 is equal to a times, that's going to be 1 cubed minus 2 times 1, minus 5 times 1 squared plus 10. 24 is equal to a times 1 minus 2 minus 5 plus 10. So we're going to have negative 1, negative 6, so that's going to be 4. So a is going to equal 6. So they've asked you for the polynomial, so we're going to go back to the polynomial. So it's going to be f of x. My a is 6, and this is going to be multiplied by x cubed. Now I'm writing it in descending powers, minus 5x squared minus 2x plus 10.